the group that I work with is focused on optimizing human performance in extreme environments. So we get to work with divers, pilots, aviators, high-altitude operators, astronauts, and even high-intensity mission operators. This is kind of on the military side of things. And what's really cool about what we do, at least I think is really cool about what we do, is we get to look at humans who are otherwise outliers compared to the general population when it comes to their physical capabilities, their cognitive capabilities, and we watch them being pushed to their extremes because of the stresses of the environments that they're working in. And so what we get to do is we get to look at those stresses, find ways to protect against those stresses, and bring those individuals back to the baseline of their already awesome selves. These approaches, or a lot of these approaches, don't just apply to the individuals that we work with who work in these extreme environments, but they apply to all of us. So when we think about optimizing human performance, we look at it in 3 components. And again, this applies to all of us. So readiness, being prepared to handle the task at hand or what's getting ready to come up. Resilience, being able to handle the stresses as they occur while you're completing that mission or task. And then recovery, which is pretty obvious. And one thing I really want to emphasize is that we always want to hit all 3 of these. If we, even just collectively as a general population, are not hitting one of these, we're essentially doing disservice to the other 2 that we've been working so hard on. So for example, if you're focusing on readiness and resilience in your daily life, but you're not focusing on recovery, you're setting yourself up for issues down the line. So we want to make sure we're tackling all of these when we're thinking about optimizing performance for the individuals that we work with. So first and foremost are our genetics. And so we're interested in looking at genes that are related to susceptibility to the stresses that we experience in these extremes. But our genes aren't the only thing that drives how we respond to environments. And we used to think it was kind of our genes were static and it is what it is, but we're learning a lot more about epigenetic changes. So essentially these are changes that occur that are kind of physical changes to the genes on the outside of the gene structure that impact how a gene is ultimately expressed. And some of these changes can be really, really good, and some of these changes can be really, really bad. And some of these changes can be passed on offspring, and some can be reversible. So there's a lot that we're still learning about epigenetic changes. But what we're interested in looking at is how does the body adapt to these extreme environments? How quickly does it adapt? What's happening at the molecular level? And is some of this due to epigenetic change? And one other component of this, I'm just going to brush on briefly, is the idea of gut bacteria, the gut microbiome. So we're learning more and more that for every human cell in our body, we have about 10 bacterial cells. But they drive a lot of the processes in our body, and it's really fascinating as we're learning more about these gut bacteria. And things like the ketogenic diet or exogenous ketones do impact, and we're learning more about how they impact our gut microbiome. Changing your diet, that's going to change the gut bacteria that you have, and whether or not that's beneficial or not is kind of the big question right now. Our community, especially when we start to look at environmental performance, we always look back to the clinical community to see what they're learning in their space. And we know that the gut microbiome changes or drives a lot of these epigenetic changes that we see and how our body adapts to different environments and different stressors that we put it through. So we're trying to look at building kind of multimodal models, not only to understand the stresses, but also be able to track the stresses, and then look at interventions such as things like exogenous ketones. There's a lot of research being done in this area, but it's really exciting to kind of be at the forefront, figuring out how our bodies are adapting at the molecular level.